In the previous sections, we have learned how to derive or find the derivative using 4 steps procedures that involves limit. In these sections, we are going to develop rules for finding derivatives that do not involve limits. Yay! Okay. However, it is important that we master the limit process in the previous sections in order to fully comprehend and appreciate the various applications we will consider. Okay, so before exploring these rules, we list some symbols that are often used to represent derivative, which is this one, f prime of x, y prime, dy over dx. So if you saw this kind of symbol, it represents the derivative. Let's begin with the first one, which is the constant function rule. So the constant function rules state that if y equal to f of x or equal to c is a constant, then f prime of x equal with 0. Also, if y prime equal with 0 or also y prime equal with 0 and dy over dx equal with 0. So these are the derivative. Now consider if you have a f of x and f of x equal with 3. On the previous sections, we learned how to find the derivative of f of x. We'll then have f of x plus h first, right? And then after we have f of x plus h, then we subtract it with f of x. And then after we subtract it with f of x, then what we do is we divide it by h. This is the third step, and then go to the limit of h approaching 0 for f of x plus h subtract with f of x over h. Okay, so what is a f of x plus h? Don't say it is a 3x plus h. No, if you have a f of x equal with 3x, then if you thought to find f of x plus h, then it is correct to put 3x plus h in parentheses. But in this case, we will not put 3x time added with h. The difference between the first and the second is that the second, it has a variable. This one, it doesn't have a variable. So it will be just 3. Okay? Yeah. Because it doesn't have a variable. And then we'll have 3 subtract with 3, which is f of x plus h is 3, and then subtract with 3. And then that will be equal to 0. And we'll have 0 divided by h, which is equal to 0. So limit of h approaching 0 for 0. So that will be equal to 0. Okay, so that's how we get that the constant functions rule for the derivative is equal to 0. The other way to look at it is this. Geometrically, f of x equal with c will be a horizontal line. So when it has a horizontal line, it means that the slope is equal to 0. Remember that the derivative is a slope of tangent line. For the horizontal line, the slope will be equal to 0. So that's why when you have f of x equal with c, then you'll get the derivative is equal to 0. Let me show you this one. So find f prime of x for f of x equal with negative 24, negative square root of 7, 12, or negative pi. All of this answer will be equal to 0. Yeah. Okay, so let's move to the second, which is the power rule. So on the power rule, it states that if you have f of x equal with x to the power of n, where n is a real number, of course, then the f prime of x will be n times with x to the power of n minus 1. So let me try to prove it first before we come to these situations. Let's say f of x equal with x squared. Then if we try to find the f prime of x, okay, the same thing, that we will put f of x plus h, and that will be x plus h squared. Then it will be x squared plus with 2xh plus with h squared. And then if we put it f of x plus h subtract with f of x, then we'll get this subtract with x squared, right? We'll get that's equal to 2xh plus with h squared. If we divide it by h, then we'll get 2x plus with h. Now if we put limit of x approaching, sorry, not x again, I always put it wrong, h approaching 0 for f of x plus h minus f of x over h, then this will be equal to 2x. Yeah, almost put 0. So the reason is because the h we can just substitute with 0 and then you'll get 2x. Now this work for x squared. And what happened with x to the power of 3 and the other x to the power of n? Apparently for x squared you have 2x. For x to the power of 3 you get 3x squared. So it's like this exponent multiply or becomes a constant over here and then subtract with 1, right? So you get 2. If you have x to the power of 4 moving here, and then the exponent subtract with 1, so you get 4x to the power of 3. X to the power of 5, then you'll get 5x to the power of 4 by putting the 5 over here and then n minus 1, 5 minus 1. So it becomes a pattern. If we have something like x squared or x to the power of n, then the derivative will have this pattern, n times with x to the power of n minus 1. Let's try some of the problem. Okay, so if we have for a x to the power of 6, then what is the f prime of x? So again, this will be 6x to the power of 6 minus 1, and then we'll get 6x to the power of 5. This is the answer for A. For B, x to the power of 30, so we will get y prime equal to 30 x to the power of 30 minus 1, so we'll get 30x to the power of 29. Okay. C, okay, C, I'll put it over here. Y equal with t to the power of negative 2. What is dy over dt? So same thing, this is the derivative. We'll get negative 2 t to the power of negative 2 minus 1, and then we'll get negative 2 t to the power of negative 3. D, okay, x to the power of 3 over 2, so we'll get d of x 3 over 2 over dx, then it will be 3 over 2 x to the power of 3 over 2 subtract with 1, so we'll get 3 over 2 x to the power of half. Isn't it easier this way instead of we have to put 4-step procedures? It will be easier, right? But again, it came from the pattern that we learned on how to approach the derivative using limits. Okay, let's move to the third one. Oh, I forgot, there's a match problem 3. So on match problem 3, you have like A, this is for 1 over x. So 1 over x, we have to know that it will be x to the power of negative 1. Okay, and if we know that f of x is equal with x to the power of negative 1, then f prime of x will be equal to negative 1 x to the power of negative 1 minus 1. So that will be negative x to the power of negative 2. Okay, this is for A. B, okay, so B, again, we put it on the exponent form, so we'll get y equal with u to the power of 2 over 3. And we can just put it y prime equal with 2 over 3 u to the power of 2 over 3 minus with 1. So then we'll get 2 over 3 u to the power of negative 1 over 3. Yeah, easy, right? Okay, C, this part, okay, we can state it as this is equal to, so 1 over square root of x is equal to 1 over x to the power of half since it's on the denominator, we can also put it as a x to the power of negative half, right? So when we are told to find the derivative, I'll just put y prime, okay? That will be negative half x to the power of negative half minus with 1. So we'll get negative half x to the power of negative 3 over 2. Okay, now let's have the third theorem. This is the constant multiple property, which is when you have a constant like 2 times with x to the power of 3, then what will happen? The constant will be stay the same. Okay, the proving is over here. It's all on your textbook also. So the proving is using the 4-step procedure, which is f of x plus h, which is ku x plus h. Okay, I leave this for you to read on your textbook. It's on your textbook. It's on your textbook. Okay, I keep saying that. Okay, so you'll have y prime equal with k times with u prime. So you just concern on the u prime. Okay, what is the example? This one. This, it has a constant 4. Okay, b, it has a constant 1 over 12. C, it has a constant 1 over 3, and then D, it has a constant 0.9. So same like before, I can just put f of x equal with 4 times the x to the power of 5. Then based on the theorem, f prime of x will be equal with 4 times with, now what I will need to derive is only this one, x to the power of 5. Okay, so that will be 5x to the power of 5 minus 1, so that will be 4, and then simplified as a 20x to the power of 4. Okay, let's try it for b. b, f of x equal with 1 over 12 t to the power of 4. I'm sorry, this is dy dt. Wait, okay, I'll just put y over here, and then y prime will be 1 over 12 times with 4, right, times with t to the power of 3, because 4 minus 1, so you get this, and then simplify it. Don't forget, you'll get 1 over 3 t to the power of 3. Simple, yeah? Okay, c, I keep saying simple, yeah, but I don't know if you find it simple or not. I hope that, yeah, you can find that this is simple. So y equal with 1 over 3 x to the power of 3, we can also write it 1 over 3 times the x to the power of negative 3. Okay, this is on algebra, yeah, so we can convert it like this, and then y prime will be equal with 1 over 3, stay the same, and negative 3 times with x to the power of negative 4, because negative 3 minus with negative 1, negative 4, and we can just put it as negative x to the power of negative 4. Okay, D, last one, we have 0.9, okay, times with, in this case, x to the power of 1 over 3, or I can just put it as 0.9 x to the power of negative 1 over 3. Okay, so we can get, let's say, y prime by having 0.9, this is still same, and then we times it with negative 1 over 3 x to the power of negative 1 over 3 minus with negative 1, so negative 4 over 3, and then we'll get that this is negative 0.3 x to the power of negative 4 over 3. Okay, the last theorem that we are going to have is the sum and difference property. So it says that if you have f of x equal with u of x plus minus v of x, such as this one, like 3, this is 2 terms, right, and we can just like quote unquote distribute the derivative. So you just look at one by one. So this is the additions. Okay, this is just the additions. It's not a multiplications like before. Okay, and for a, f prime of x, yeah, we'll have f prime of x. For f of x will be, look one by one, 3x to the power of 4. So 4 times with 3, 12, and then x to the power of 4 minus 1, 3. Okay, so this will be 12x to the power of 3. And then minus with, over here, negative 2 times with 3, and then x to the power of 3 minus 1, 2. So negative 6, x to the power of 2. And then plus with 2x, I'll put it over here, negative 5, and then we have plus 7, which is the constant, plus with 0, so I don't put plus 0 because that will be 0, okay, or I'll just change this, that's better. Okay, so I put negative 5 over here. For b, okay, b, the y prime will be equal to, look one by one, the first term is 3, so it's a constant. The derivative of 3 will be equal to 0. The derivative of negative 7x to the power of negative 2. So look one by one, negative 2 times with negative 7, positive 14, right? Positive 14, and then x to the power of negative 2 subtract with 1, and then we'll get negative 3. So the answer is 14x to the power of negative 3. Okay, C is almost the same. Y prime will be equal to, the first term is 5v to the power of 3, that will be 15v square minus with, you have v to the power of 1 over 4, 1 over 4, v to the power of, so if you have that this is v to the power of 1 over 4, subtract with 1, you'll get negative 3 over 4. Okay, and then D, this is also the same. Okay, so we'll get the answer for the derivative will be, look one by one, I'll just put it this way, negative 3 over 4 x to the power of negative 1, yeah, plus with 4 x to the power of negative 3 minus x to the power of 4 over 8, sorry, and then the derivative y prime, that will be equal to, we'll get for the derivative is negative 1 times with negative 3 over 4, and then that will be 3 over 4 x to the power of negative 1 subtract with 1, so we will get negative 2 plus with negative 12 x to the power of negative 4, and then minus with over here we have 4 times with 1 over 8, which is half, and then x to the power of 4 minus 1, which is 3, so we'll get negative half x to the power of 3. Okay, now it will be useful if we are told to find this kind of derivative. Find this one, 5 minus 3x plus 4x squared divided by x. So what we need to do is actually put it as the f of x equal with 5 over x minus 3x over x plus with 4x squared over x. Now you don't need the quotients rule to solve this one. You can, but you will get the same result. Quotient rule, by the way, you are going to have it on chapter 3. So this one, if you can put it this way, you can have f prime of x again equal with, let me put it this way first, f of x equal with 5x to the power of negative 1 minus 3, right, plus with 4x. So the first term will be negative 5x to the power of negative 2 minus 3 over here, the derivative will be 0, and then plus with 4x, the derivative will be 4. Okay, plus with 4. Just in case if you don't know how to get a 4x equal with 4, 4x is actually 4x to the power of 1. So when you get the derivative, then it will be equal to 1 times with 4, 4, and then x to the power of 1 minus 1, which is 0. So that will be 4x to the power of 0 or equal to 4. So this is the answer. Okay, I'm sorry, I should put that this is G and G. Okay, now let's have some example on the word problems. An object move along the y-axis and it's given by these functions. Find the instantaneous velocity functions phi. So I don't know why this is phi. It's supposed to be, you know, x. Yeah. Sorry, functions f of x. I mean, so a. Yeah. Take a look. Then f prime of x will be equal with x square. Sorry, not x square. We will have 3x square minus with 30x, right, plus with 72. Okay, so x cubed, that will be 3x to the power of 3 minus 1 square, and then negative 15 times with 2, negative 30, and then to the power of, times with x, plus with 72. Okay, now b, find the velocity at x equal with 2 and x equal with 5 seconds. When it asks you the velocity, it means that it's the derivative, the instantaneous velocity at that point. So what you need to do is just to put f prime of 2 and f prime of 5 and put it into the equation. 3 times with 2 square, you know, minus with 30 times with 2 plus with 72, and then this is also same, 3 times with 5 square minus with 30 times with 5 plus with 72. Wait, okay, so f prime of 2, 3 times with 4, which is 12, added with 72, that will be 84, minus with 60, then we'll get negative 24. And then we have over here 3 times with 25, 75, added with 72, 147, minus with 150, that will be negative 3. Okay, let me check. Oh, sorry, this one is supposed to be positive 24. Okay, C, find the time when the velocity is 0. So it means 0 equal with 3x squared minus 30x plus with 72. What I will do is to put the common term. So 3, that's the common term, and then I'll have x squared minus 10x plus with 21. Okay, and then I can just put it 0, 3, factor it out, 3 minus x minus 3, x minus 7. So then we'll have that it will happen at x equal with 3 and x equal with 7. Okay, so let's do the last problem. Tangents. Let f of x equal with x to the power of 4. Find the f prime of x. Now let's try to do this. X to the power of 4, the derivative will be 4x to the power of 3, right, minus 24x to the power of 2. Okay, this is f prime of x. B, find the equations of the tangent line at x equal with 1. So f prime of 1, then we'll get 4 times with 1 minus with 24, that will be negative 20. Okay. C, find the value where the tangent line is horizontal. The tangent line will be horizontal when the slope is equal to 0. So 0 equal with 4x cubed minus 24x squared. Find the common terms. The common terms will be 4x squared and then times with x minus with 6. So the one that contribute as a 0 will be 0, x equal with 0, and then x equal with 6. That's our lesson for today.